method of separating technique is our simple distillation. And simple distillation can be used to separate a solvent from a solution. So this is, we're actually using the same solution, copper sulfate solution. In some ways it's similar to evaporation and crystallization, but the problem with those two methods is that when we heated the solution in an open container, so either our salt solution or our copper sulfate solution, the problem was that we lost our solvent, in both cases water, because we heated them in an open container, an evaporating basin, and the water just simply evaporated off as a gas and would have then mixed with the air. So we lost the solvent as such. So what we can use this simple distillation to do is to separate our solution, and what we'll get at the end is our solute, but we can also collect our solvent. So we'll be left with our solute in the round bottom flask, and we will collect our solvent, our water in this case, in our flask here. So that's what we use simple distillation for. So this is the apparatus setup. You can see that it's quite complicated and there's lots of different parts to it, but I'll talk through those parts as we go along. First thing I want to talk you through is this condenser. It's sometimes called a Liebig condenser. And essentially what that will do is that will cool our gas during the experiment. So essentially what we'll do is we'll start heating this solution in our round bottom flask here. The water will evaporate just as it did with evaporation, but what will happen is it will pass through this tube into the condenser. And when it gets to the condenser, what it will do is it will cool down. Why does the gas cool down? Well, what we have in this condenser is actually two tubes. There's an inner tube where our gas will pass through, but then there's also an outer tube around that. Think of almost like a toilet roll inside a kitchen roll. So the toilet roll is smaller, so there'll be a bit of space around the toilet roll surrounded by the kitchen roll, if that makes sense. And essentially in that gap is running some cold water. And so you can see these tubes are connected. One is connected to the water tap here. We always put water in at the bottom and then it's pushed up the condenser and it will come out the top. And remember, this is in the outer tubing, so it's not actually mixing with the gas that passes through the inner tubing. So I'll show you what happens here. The water is not flowing at the minute. You can see if I hold the tap up, there's nothing flowing out. But if I turn the tap on, we don't want it too strong, but have a look at the condenser, see if you can see the water starting to flow through. Okay. So what is happening now? It's hard to see because water is a colourless liquid, but what is happening now is water is entering the condenser here. It's flowing around this outer tubing, so around the outside of the condenser, and then it's coming out here and coming through this delivery tube and out here. So you can see there's no water actually flowing through the inner tube, it's all around that outer tube. And if I hold that, it's very, very cold. So what is going to happen is our water will evaporate, the gas passes through into the condenser, and then it is cooled down because of that cold water flowing around the outside. It's essentially just providing a really cool surface, a bit like in the mornings in the winter where you see condensation on the window because the water vapour from the air is cooling down on the cool surface and condensing into a liquid. So we'll see that when we get our distillation going. So I'll just turn that on a little bit more. We don't want that on too much though. So let me flip around now to the start of our experiment, the start of the apparatus. So what we've got here is what we call a round bottom flask. Literally it's a flask that has a round bottom. And what we're going to do is we're going to heat the solution inside. The solution we've got in here is copper sulfate solution. We could also use solutions like our salty water, and that would allow us to collect the salt and also the pure water. And this is a way of collecting pure water, and for example on cruise ships where they would take water from the sea and they can use distillation to actually get pure water. That means water with nothing else dissolved in it, and this is something we can use for that. Now, inside the flask, it might be hard for you to see, but we have a few little small white solid granules, and these are called anti-bumping granules. And essentially they are little solid particles that don't dissolve in our solution, so they don't affect the composition of the solution as such. But what they do is the exam reference is they promote smooth boiling. They essentially make sure that this doesn't bubble up too much. So the boiling will be nice and smooth. We'll get nice small bubbles in our solution rather than it kind of bumping around as such and splashing around our flask, because we don't want too much splashing in this flask, and we certainly don't want any liquid splashing up into our condenser. We want that just to be our pure gas, which will be steam as such. Okay, so that's anti-bumping granules, and we say that they promote smooth boiling. So let's get this process going. To get this process going, I need to heat my solution. So let me turn on my Bunsen burner. There we go. And again, we don't heat it too strongly because it is a solution, it is a liquid as such. So we don't want to put on the roaring flame, but we'll put it roughly on the half open and half closed flame and heat this gently. Okay, so this is going to heat the solution, and what will happen, as with evaporation, it will cause the water to evaporate, but the solute, which in this case is our copper sulfate, will not evaporate. It will not melt or evaporate, because its melting point and boiling point is a lot higher, so it will leave the copper sulfate particles behind. So that's starting to heat now. Other parts of the distillation apparatus is a thermometer here, and you'll see the bulb of the thermometer is just at this junction before it goes into the condenser, because what we want to do is we want to measure the temperature of the gas as it passes into the condenser, and that can allow us to identify the gas as such. So water, for example, has a boiling point of 100 degrees C. So what we should see is that when we see the gas starting to pass into the condenser, the temperature on the thermometer should be 100 degrees C as that gas passes across it. So we don't have any water evaporating just yet, but the temperature on the thermometer is increasing. So it's about 35 at the minute. I'll maybe open this up slightly more to get it going a little bit quicker. You can start to see a little bit of condensation at the top of the round bottom flask, which means some gas is starting to evaporate, but it's cooled down just at this stage. What we want it at is the point where the gas is going to actually pass up and into the condenser. Okay, so what you can see now, we've left this running for a minute or two, and we can see that our solution is starting to boil. So you can see that with the bubbles that are forming. And what is happening is our water is evaporating. You can see the temperature on the thermometer is 100, it's maybe 101 degrees, but it's very, very close to 100, which tells us that the gas that is passing our thermometer bulb is at 100 degrees C. And what we can see now in the condenser is that the gas has actually passed through into the condenser, and you can see that with the steam here. But what's happening is you can see some water actually flowing through at this end. So it's a gas really up here, but as it cools, it will condense and form a liquid. That's the change of state from gas to liquid, is condensing. And you can see the water flowing through, and it's being collected in the flask here. And what you can see is that the liquid that we're collecting is colourless, and that tells us that it is pure water, so there's no more copper sulfate dissolved in it. If there was any copper sulfate dissolved in it, it would be blue, but you can see it's a nice colourless liquid, and that is pure water. So that is water with nothing else dissolved in it. It's a pure substance. And essentially we just keep this process going until the solution in the round bottom flask has totally disappeared, and what we will be left with is just our copper sulfate solute that is no longer dissolved in the solution. So again, solution is heated, water evaporates and forms a gas, steam. The steam passes through into the condenser where it is cooled down. Why is it cooled down? Because it's got cold water running around the outside. So if I touch that, it's very, very cold because of the cold water running around the outside that is being pushed in at the bottom and is flowing out at the top. And so the gas condenses and forms a liquid, and that liquid is collected in the flask here. So our distillation process is now finished. We can see that no more liquid is being collected in our flask here. There's no more liquid dropping down. And if you have a look at the round bottom flask, what we're left with is, hopefully you can see in there at the bottom, we have some blue powder, which is our copper sulfate. And anything that is blue is hydrated. So it still contains some water bonded to it, but it's no longer a solution. It is a solid. But you can hopefully see on the outside as well, we've got some white powder. And that is anhydrous copper sulfate. So that is copper sulfate where the water molecules have been totally removed, and it would be white, which we'll see later is our chemical test for water. So anhydrous copper sulfate is white, but the hydrated is blue. But the point of this separating technique was to separate the solvent from the solution. So you can see this is a method where we use evaporation followed by condensation to collect our solvent, which is in this flask, but we also have been able to collect our solute or keep our solute in our round bottom flask. So that's the method of simple distillation.